In this lesson, we're going to be looking at phase changes. Now, we know that it takes energy to raise the temperature of a substance. However, it doesn't matter how long you boil a pot of water on the stove. The water, pure water, will never be more than 100 degrees at 1 atmospheric pressure. I mean, there are other things that go on with it, but water will reach a maximum temperature of 100 degrees Celsius. And no matter how much energy you keep putting in, how much fire underneath it, the water will never go above 100 degrees. So my question is, where does that energy go? What happens to it? Well, let's answer that question. Energy is released when things freeze and condense. Okay, so when things go from gas and go from liquid, not gas, go from liquid, they freeze and become a solid. Or when they condensate, so when they go from gas and become a liquid. Okay, this is a release of energy. This is a phase change. Freezing and condensing are phase changes that release energy. But what happens when you boil that water is you put it through a phase change. You have it vaporize. So melt is solid to liquid. Vaporize is liquid to gas. So what happens is that energy goes into making the gas vaporize, or the water vaporize into steam or gas. So all that energy doesn't go into changing the temperature. Alright, Q equals MCAT. It doesn't go into changing the temperature. That heat energy goes into the phase change. So temperature doesn't change during the phase change. After that's become gas, it can become hotter. Steam can be hotter than liquid, than the boiling water. There's a different maximum temperature for gas. What you end up with is a graph that looks like this. Now, during this part and this part, it's going through phase changes. Okay, those are phase changes. And the temperature isn't changing, right? So during these slanted parts is where you're adding heat. Heat is being added and the temperature is going up. So during the red, you'd use Q equals MCAT to find out how much your temperature goes up and things like that. During the green, your temperature doesn't change despite adding heat. So we're going to see a different equation for those times. Now, the two equations that you'll see in your reference table is your heat of fusion equation, and you'll also see heat of vaporization. Heat of fusion has a symbol HF. Now, HF is that heat of fusion constant. Okay? It's measured in joules per kilogram, and it's the energy required to melt 1 kilogram of substance. So HF is similar to C, your specific heat. So during those flat parts of the graph, what's happening is your heat is going into changing a certain amount of your mass. So how much of that water turns to steam depends on the amount of heat energy added times, or heat energy added and the specific heat. So we'd go down here and we'd say, okay, heat of fusion deals with the phase change between solid and liquid. So we'd say, okay, water to ice, ice to water, has that constant. Next, we're going to look at heat of vaporization, which has a different constant. Now this is what it looks like in your reference table. Heat of fusion, and then we have heat of vaporization, which we're going to look at next. Now heat of vaporization, that's symbol H sub V. Units are joules per kilogram, and it's the energy required to vaporize, or to turn something between a liquid and a gas. This vaporization is the liquid to gas. Fusion is solid to liquid, or the other way around. Okay, we have our own constants for it, and it's the same equation, just H sub V instead of Q sub V. So if we were to go back to our wonderful table, here you would use Q sub V equals M H sub V. So if you want to know how much heat is needed to vaporize 2 kilograms, you would use that equation. You'd have to reach, let's say, your 100 degrees of water, and then you'd have to keep adding heat until it's all vaporized, and then its temperature will go up. And this one down here, this flat line, would be heat of fusion. Okay, and Q equals MCAT is each of the slanted parts. So at each part, you can do a different solving of an equation. You'd have different numbers at each part. Alright, let's look at a question. How much energy is needed to change 2 kilograms of 0 Celsius ice into 0 Celsius water? So when you're going from ice into water, your temperature isn't changing. Water can be 0 degrees and ice can be 0 degrees. You need a certain amount of energy to change between that. Okay, so if we're doing a phase change from ice to water, well, that's solid to liquid, so that's heat of fusion equals M times H of fusion. So we're looking for the amount of energy, so we're looking for Q equals mass, which is 2 kilograms, times H sub F. And we look for ice to water, and that would be 3.34 times 10 to the 5th. And we get 668,000 joules, which is the same thing as 6.68 times 10 to the 5th joules. So it requires that much energy to change 2 kilograms of water into ice, or from ice into water. Alright, that's it for the lesson. Don't forget to complete your homework. Good luck.